So first thing we're going to be dealing with today is putting parabolas into vertex form. So first off, standard form, you should be used to it. ax squared plus bx plus c, that's the form that we were using the entire time last class. You need it to factor, you need it to do completing the square, you need it that way to use your quadratic formula. So anytime you're solving, we need standard form. So I know for a fact, Algebra 1, you talked about this. I think you talked about it a little bit last year in geometry. Vertex form, a times x minus h squared plus k. That is the other way we can write our parabolas. Vertex form is helpful, especially with word problems that are dealing with the maximum value or the minimum value, because then you can just pick the answer out right away. Your vertex ends up being the point h comma k. So you change the sign of the h, so whatever's with x, you change the sign of it, k stays the way it is. So in order to do this, we use our completing the square process. So I kind of review that a little bit there. So let's take a look at examples. First one, we're going to rewrite that equation in vertex form and then state the vertex. So with vertex form, I do it a little bit different than some other teachers do. Some people, what they would do is they would tell you to take your 5, move it over to the other side, and then add your spaces on both sides. But it's just a whole bunch of extra work. You're moving stuff over to one side of the equal sign, then you're moving it back. So what I like to do is I like to set it up like this. So I put plus a space after my x term, just like you would in normal completing the square. But on the same side of the equal sign, I also subtract a space. Why would I add it and subtract it? Yeah, because it just knocks each other out. If I add a 3 and then subtract a 3, did I really change anything? No, it just ends up being a 0 in the long run. So that's why we're going to do plus a space and minus a space for vertex form. So just like we were doing for completing the square, what number would go in our space? 1. Because you would do half of 2, which is 1, and then you'd square it, so it's still 1. So we still have our perfect square trinomial there, our x squared minus 2x plus 1. How would that factor? X minus 1 squared. And then for the end, 5 minus 1 gives us a plus 4. And then it's in vertex form. So our vertex for that one, again, you change the value of the number that is with your x. So instead of minus 1, it would become positive 1, and then 4 stays the way it is. So our vertex is the 0.14. All right, so let's try the second one. Same process. So I'm going to put plus a space after my 8x, and then minus the same space after my 7. I'm not trying to change my equation, I'm just trying to rewrite it in a different way. So what number is going in our space? 16. So those first 3 terms there, how does that factor? X plus 4 squared. And then 7 minus 16 gives us a minus 9 at the end. So there's our vertex form. Where's our actual vertex, though? -4, -9. Again, the number that comes out from x, you just change that sign, the other one stays the way it is. So our third one, though, I can't do completing the square yet, because we got that 2x squared out in front. So what we have to do for that is we will first do kind of a GCF factor. We're going to take that 2 out. I don't want to divide everything by 2 like you can with solving, because that 2 still has to be there. It does affect your answer partially. So that gives me x squared plus 8x. I'm still going to put my space in there, same process. And then plus 12.5, because 25 divided by 2 is 12.5. And then minus my space. So what number goes in the space? 16 again. So this trinomial factors into x plus 4 squared. Again, I still have that 2 hanging out in front. 12 minus 16, if my brain is working, should be negative 3.5, so minus 3.5. So we can't find our vertex yet because we've got that 2 on the outside of everything. So what we need to do is we're just going to distribute this 2 kind of back through. But that 2 is just going to hang out in front of the x plus 4 squared. Because remember, order of operations, exponents would happen first. So I would have to square this first, and then I could multiply everything by 2. But I don't want to actually square it, so we're just going to leave the 2 out in front of it. And then 3.5 times 2 gives us minus 7 at the end. So our vertex would be the point negative 4, negative 7. All right, circle formula. Do you guys remember standard form per circle? Probably not. Circles, you have both x squared, you got a y squared, you got an x in there, you got a y in there, and then you've got another number known as constant that's also in there. Now the formula you're probably more used to is the actual center radius form. That's x minus h squared plus y minus k squared equals the radius squared. So this one's a little different than our vertex form with our parabolics was y equals, or if it was a function, it would be f of x equals, whereas this one is equal to the radius squared. So it's always equal to a number. Our center would end up being the point hk still, h coming from the x parenthesis, k coming from the y. And the radius is just your r. What you end up doing is whatever number you have over here, you end up having to take the square root of it. And that's how we end up getting our radius. So again, we end up doing completing the square for this. But you just end up doing completing the square twice. You got to do completing the square for your x's, you do completing the square for your y's, and then you do your factoring. So let's take a look at the first one. So we want to get the x's together first. So I'm going to start with my x squared. I'm going to move my 10x over with it and then put my plus a space. So all of my x's are there. And then we want to get all the y's together. So my y squared and then my minus 6y and then plus a space. This time you do absolutely want to move that 75 over because again, it's supposed to equal the radius squared. So you got to bring that number over to the other side. And then you still have to add 2 spaces. One space is from the x's, one space is from the y's. So do completing the square for the x and what goes in that space? 25. And then how about for the y's? 9. So the x's, when factored, would end up being x plus 5 squared. What would our y's be when factored? There you go. Y minus 3 squared. And that equals 700, 109. Yep. And there we go. So we are in center radius form. That was our first part. The center of our circle would be at negative 5, 3. Whenever you take the number out of the parentheses, this time you're doing it twice, change the sign each time. And then our radius would be the square root of 109. There is no perfect square that goes into it, so it stays that way. Number 5 is kind of like our last one that we did with our parabolas. We've got a 2x squared and we've got a 2y squared. We can't do completing the square with those being 2's. So we're going to GCF out a 2 first. So that gives me x squared minus 2x plus your space. Just putting all my x's together. And then plus y squared plus 8y plus a space. And that's even going to happen with the 6. So the 6 becomes a 3 because I got to factor a 2 out of it. All right, completing the square for the x, what number goes in the space? 1. How about for the y's? So the x would factor into x minus 1 squared. Again, I still have 2 parentheses. The first one is from that 2 being all the way on the outside of everything, and then my x minus 1 squared is in a parentheses. So then for the y's, that would factor into y plus 4 squared. And it's going to equal 20. So then we just have to bring that 2 back through so that we can get our accurate radius there. So it's going to be 2 times x minus 1 squared. Again, it can't go through the parentheses because of the square. That should happen first. And 2 times y plus 4 squared is going to equal 40. So our center is going to be the point 1, negative 4. That 2 out in front does not change that at all. And our radius would be 2 radical 10. Now I know you could put that in the calculator and get a decimal, but what they always want for this is what they refer to as exact value. They don't always tell you that, but that's what they're looking for. So writing it as the radical is exact value because you're not rounding anything. You're writing the answer as it is. All right, last one for our circles. What should we do first? Yes, GCF out of 4 first. That gives me x squared minus 6x plus a space. And y squared plus 18y plus a space. It's going to equal 19 plus 2 spaces. So what goes in the space from our x? 9. And then for our y, $81. So I'm going to try to do 2 steps in one. How would my x's factor here? Minus 3 squared. And I'm going to put my GCF of 4 back in front of it. And then the y's, yes, would be y plus 9 squared. But again, I'm going to put that 4 back in front of that one also. I'm just kind of redistributing it as I factor. Then on the right side of the equal sign, 19 plus 9 plus 81. 109. And then times the 4. Makes it 436. So our center would be the point 3, negative 9. And our radius would be 2 radical 109. The only number to come out of there is a 4. Sum and product of the roots. So we have our quadratic equation. They always produce 2 different roots for us to use. So if we have the equation, and you're just trying to quickly figure out what is the sum of the roots, the sum of the roots would be negative b over a. So whatever your b value is, you just negate it and put it over your a value. Product of the roots would be c over a. So you just take whatever your c value is, put it over your a value. And that's how you can figure out sum product quickly. Now let's say you were told to write the equation for a quadratic and they give you the 2 roots. Back in Algebra 1, you learned a very long way to do it. But using the sum and the product of the roots, you could just add them together, find your sum, multiply them together, get your product, and then you would use this formula. It's x squared minus the sum times x, and then plus your product. And then it equals whatever notation they tell you to use. It can equal 0, it can equal y, it can equal f of x. That part really doesn't matter unless they tell you. So let's play around with this. Let's try it out a little bit. Number 1, what is the sum and product of the roots of 5x squared equals 20x minus 1? First thing we got to do is get it in standard form, get it equal to a 0. So I would subtract 20x and add 1. So we get 5x squared minus 20x plus 1 equals 0. Now again, our formula up above, sum is negative b over a. So what is our b value from our quadratic there? Negative 20. So that's going to turn into positive 20 because you got the negative from the equation and it's negative 20 that you're plugging in. And then our a value is 5. So 20 divided by 5 gives us a sum of 4. So that means our 2 roots, whatever they are, when added would give us a 4. So then our product, again, using our little formula up above, is c over a. Our c is a 1, our a is a 5. So our product of our 2 roots would be 1/5. And that one's done. Sum, product, that's it. Number 2, they want us to write a quadratic equation with the roots of 5 plus or minus the square root of 6. So first thing we got to figure out is what is the sum of the 2 roots. So 5 plus the square root of 6, add to it 5 minus the square root of 6. What happens with our 2 square roots? Cancel. So our sum is a 10. So now we got to figure out our product, so we're going to multiply the 2 of them. So 5 plus the square root of 6 times 5 minus the square root of 6. But what are these 2 things? Conjugates. So how do we multiply conjugates? First 2, last 2. So 5 times 5 gives me a 25. Radical 6 times negative radical 6 just gives me a negative 6. So my product is a 19. 25 minus 6 gives me 19. So then our equation, x squared minus the sum times x, so minus 10x because our sum was 10, plus the product. And then you just have to set it equal to something. So we can set it equal to 0 here. All right, our third one there. Verify that 1 plus or minus 2i are the roots of the equation x squared minus 2x plus 5. So let's go with sum first. So the two they want me to verify, I'm going to actually start off with adding them together. So 1 plus 2i plus 1 minus 2i gives us a what? 2, because those i's cancel. But then I'm going to look at the equation and use our little formula from up above. Sum is negative b over a. So what is our b value from the equation? Negative 2, so that turns into positive 2. A would be a 1, so it ends up being 2 over 1. Is that the same as 2? Yeah, so far so good. So now I'm going to go into product. So 1 plus 2i times 1 minus 2i. These again are conjugates. So 1 times 1, 2i times negative 2i. What does that simplify into? 5. It'd be 1 plus 4, so 5. So from the formula, it would be c over a. What's our value of c? 5, and then a is a 1. 5 is the same as 5. So, yep, product and the sum were the same. So number 4, if one root of this quadratic is 1, so that is root number 1 is a 1. Find the other root, and then they want us to find the value of c, which is, you can see right now, is a question mark. So we got to find those two things. We got to figure out what the other root is. We got to figure out what the value of c is. I know my b and my a value, so I'm going to use that. That was how to figure out the sum of my two roots, was using negative b over a. So when I plug in my b, which is negative 4, turns into positive 4. My a is a 1. What does that just simplify down to? Just 4. So the sum of my two roots has to be 4. I know one of my roots is a what? I don't know the other one, so it's got to be 1 plus something. So if I subtract my 1 over, what's my something? 3. So our other root is a 3. So then to figure out our c value is used to help you find the product. C over a is actually how we use it. Again, we know our a value is a 1. So really it's just c over 1, which is c. We get that, again, by multiplying our two roots. One root is a 1. The other root is a 3. So what is our c value? 3. So in this case, the other root is a 3, and your missing value of c is also a 3. Let's take a look at the other one. So one of the roots, again, is 1. So that's my root number 1. I already know that. We got to find the other root, and we got to find the b value this time. So this time, I know c. Here's my c. I know my a. So I'm going to use my product rule, which is c over a. So that's going to put it as negative 4 over 3 is what the product of my two roots is supposed to end up being. One root is the number 1. The other root I don't know yet, so I'm going to call it x. So what does x end up equaling? It would just be negative 4/3, because 1x is just the same as x. So our other root is negative 4/3. So now we've got to find the value of b. So again, to get the sum, that's what we use b for, so negative b over a. We know a value is a 3. So this has to equal root 1, which was a 1, plus our second root, which we just found to be negative 4/3. Got to add them together. It's going to equal the sum. So what's 1 plus negative 4/3? Negative 1/3. And then there's two ways we could go about this at this point. We could cross multiply, or are the denominators the same? Yeah, we could cross out the denominators also. So negative b equals negative 1, therefore b equals positive 1.